Yeah, write this down. Page 667. So what's going to happen now is that sometimes these identities come up in solve questions. And so we're going to look at all trig equations that have the word solve in it. And what do we do when we can't solve it the normal ways of just getting sine by itself or just factoring? What happens when we have more than one trig function? And it's considered to be more than one trig function even if you have sine theta equal to sine 2 theta, because the angles are different. So we want to have our functions with only one trig function and with only theta instead of a theta and a 2 theta question. So we're going to do a couple of these examples, and then there are a bunch of questions on the back of that page with all the proofs with identities that we did. On the back side of that, there's a bunch of questions that we can solve. They're all solved ones. I haven't assigned them yet. There's a bunch circled. The circled ones are not the ones I'm going to assign. I'll tell you which ones that I'd like you to try for practice. Yes?
The sine square on 2 theta plus cos 2 theta would also be 1.
Yes, because the angle is the same. So the sine squared theta plus cos squared theta is equal to 1 whenever the angles are the same, but it's not true if one angle is something and another angle is something else. So we're going to use our double angle formulas a fair bit here. We're going to look at factoring a common factor. With Mr. Thompson yesterday, there was 2 questions which had sine and cos in them that were solved on that practice quiz that you guys worked on yesterday, where you had to factor out a common factor instead of dividing both sides. So that's a very important strategy that comes up, and we've listed it here again. And sometimes we're going to use the same strategy we use in proofs, where we change everything to sine and cos and see if we can get rid of fractions to solve our equation. So we'll look at a couple of these examples. Can I scroll down to the first example? Not yet? How many people are still ready? So here we have a question. It says solve. It doesn't say prove. So we can work on both sides. But right now we have a cotangent and a cos. So we won't be able to solve this because we have 2 different trig functions. When this is the case, we will have to say, is there ways that we can change this so that they were all the same trig function? However, there's not a way to change cotangent directly to cos or cos directly to cotangent. It isn't cotangent squared, so you can't use the fact that cotangent squared plus 1 equals cosecant squared, because you don't have a squared there. What you can do is change cotangent. So once I look at all those other strategies, I say, I'm going to change everything to sine and cos. So then I would have cos theta over sine theta equals 2 cos theta. And to make my equation easier to solve, I'm going to look at ways that I can have no fractions. How would I get rid of a fraction? Multiply both sides by sine theta. So my equation becomes cos of theta, because these sine thetas would simplify, equals 2 cos theta sine theta. Now I don't have things in one function, because I still have a sine and I still have cos. None of them are squared, so I can't change them. And this is where so many people get very tempted to do this. And this is, if you divide both sides by cos, don't you get rid of the coses? Yeah, and that would be nice, because then you'd only have sine. The problem with that is that you're eliminating a solution. Because can you see, just looking at this, that if cos is 0, you would get 0 equals 0? But if I divide by cos to get rid of it, I might be dividing by 0, which is bad. And time I write something bad on this board, it just disappears because it knows that that's not good. So instead, we make one side equal to 0, and we factor instead of dividing. I can take out a common factor of cos, leaving me with 2 sine theta minus 1, which means cos theta, which we already knew could be 0, and the other part says that sine theta could be 1/2. Both of those are on our pie plate. When is cos equal to 0? Pi divided by 2, and 3 pi divided by 2. And when is sine equal to 1/2? Pi over 6, and yes, 5 pi over 6. So there's an example where you could change it to sine and cos, and that will help you. Also going to look at sometimes with 2 thetas. So back to our strategies. Sometimes you have a 2 theta. You need to be able to recognize when is a 2 theta question one where I should use an identity and change it, and where do I have a 2 theta question where it's a multi-revolution question. So I've got some notes to help you decipher between those two. Oops. Where was that? Go down to that example that I just did. There you go.